Okay, 4.2, ecological relationships and population dynamics. So what is a population? We just did this in 4.1. So population are members of this, all members of the same species living in an area. So factors that control populations or biotic factors are competition, predation, parasitism, symbiosis. So look at competition first. So the definition of competition is a struggle between two or more organisms for a resource that is in short supply. So organisms will compete. What can they compete for? So food, space, weight, light, minerals, a mate, shelter. So all types of competition reduces the population. So there tends to be more competition between members of the same species as they're competing for the same resources. With that, we look at two types of competition. The first we're going to look at is contest competition. And again, you need to know this definition. So contest competition is a struggle for a resource with one winner. My example here is we have two male blackbirds are fighting for territory. There's only going to be one winner. Second definition is scramble competition. So scramble competition is a struggle for a resource and all will get some. So I have an example here. Plants grow in overcrowded conditions. They'll compete for light, water, minerals, space. So none of them will get all the resources. They'll all grow poorly and they may fail to flower and may fail to reproduce. So adaptations to competition. So rabbits have long ears, so their hearing is very good and they can avoid capture. So we're really qualifying that there. We're not just saying that rabbits have long ears. What's the purpose of them having long ears? So they're good hearing to avoid capture. Adaptations to competition of plants. So dandelions and grass, we're looking at the difference between the two. So they compete for water and minerals. So dandelions have long tap roots, so their roots can go further to take up more water in comparison to grass roots who have shorter roots. Now, predation. Predation is the catching, killing, and eating of organisms. Again, another definition that we need to know. So structural, competitive, and behavioural adaptations, they are necessary to allow the organisms to survive in their habitat, and that will give them a bit of an advantage. So adaptations to predators. So one example, we have sparrowhawks. So they have very sharp beaks, they have great eyesight, they've also got very long talons, and what they do is they catch younger or smaller birds in flight. Foxes. So an adaptation of a predator is a fox has excellent eyesight to help locate its prey. Adaptations of prey. Snails have shells for protection. Ladybirds, they're red, so they have formic acid, so they're not nice to taste. And then rabbits have long ears to hear their predators. So then this brings us on to draw the relationship between the predator and the prey. So the predator-prey relationship graph. So this was asked in 2024, just there recently, where students had to copy the graph and add in the predator, and then they had to explain the graph. So drawing this in now, I'm going to go with red for my prey, my rabbit, and that's always going to be larger. So I would say to my students, do at least 2 peaks leading into a third. So that's my prey. So then following that is my fox. So my fox is my predator, it's going slightly behind, okay. So 2 peaks leading into a third. So your prey will always be larger than your predator. So if you're asked, so our x-axis here, we have time. It could be in years, it could be in months, it could be in seasons. And then we have here on our y-axis is our number of organisms. So if you're asked to explain the shape of the 2 curves. So this is 9 marks there in the summer in 2024. And I think I got 1 student out of the hundreds that I corrected that got the full 9 marks in this, where they're asked to explain this graph and explain the peaks. So a large number of prey will result in larger predator numbers. So we have here a larger number of prey in the red, and then we can see we have here an increase here, our larger prey numbers, or predator numbers. So then I have the second point there, as the predator numbers increases, this will reduce the prey numbers due to loss of energy, okay, loss of energy. So here we can see our predator numbers here are starting to increase, while our prey numbers are starting to decrease due to a loss of energy. So our predators here, what they may do, so they may die because there's not enough food available. They may migrate, so that's migrate, not emigrate. Okay, so they may migrate to another area. Okay, now, if they're going to another area to migrate, this gives them time. So there's a time delay for the in the predator numbers, so they can time for them to breed, to reproduce, and to breed. So this was key in the summer of 2024, and this was key in the summer of 2024, where students did not get the marks. Now, we're going to look at factors that can contribute to the predator-prey relationship. So the first one there is availability of food. So how much food is available? Okay, so large numbers of prey can cause an increase in the number of predators. So lots of rabbits, there's going to be lots of foxes about because there's lots of food. So as the prey are killed off, there's less food for the predators. So as those foxes are eating up the rabbits, their numbers of the rabbits is going to die or drop, decrease, and their numbers fall, allowing for the number of prey to rise again. So concealment. Okay, so you might find there that your prey numbers are low, so they're hiding. They've gone to camouflage themselves, so the predators cannot find them. So this allows then the prey, the rabbits, to reproduce and build up their numbers again and re-establish themselves. And then we have movement of the predators to a more abundant location. So again, I've mentioned foxes. So the foxes, there's no more rabbits left. So the foxes now move to a new area where there is food available. So if the number of prey is low, the predator moves into new areas with more prey. So this allows the prey in the old location to increase their numbers again. So it's cyclic. It is a cycle. So the predator-prey relationship is important in controlling the size of the population. That we need to know. An advantage of introducing a predator as a biological control is that the main thing it would avoid pesticides. A disadvantage, okay, so that's an advantage. A disadvantage of using a predator as a biological control is that it could alter the food chains, okay, which may affect the balance of nature. So this would be a disadvantage of introducing a predator as a biological control. And here we have an advantage of introducing a predator as a biological control. So on to parasites. So parasites are organisms that live in or on another organism, which feeds on it and it causes a harm. So parasites can decimate populations, can reduce populations. For us, would have been the famine and the potato blight. So parasites are smaller than their hosts, so they don't need tend to do too much damage. So they do not want to jeopardize their home or their food supply. So therefore parasites, they don't want to reduce the numbers of their hosts. So remember, a parasite is an organism that lives in or on another organism. It feeds off it and causes it harm. It doesn't kill it. Now, of that, we're going to look at two examples. The first is an endoparasite. An endoparasite lives inside the host, and one example would be potato blight. Another example would be liver fluke in sheep, if some of you are doing ag. Ectoparasites, they live on the outside of their host or on the surface of the host. And one example will be mozzies, mosquitoes biting humans, another for fleas on a dog. This brings it into symbiosis. So symbiosis is a relationship between two organisms of different species. They live in close association and both will benefit. So these are different species here. So of symbiosis, we need to know different examples of symbiosis. The first example will be here, mutualism. So in mutualism, one example here, we have two organisms living in close association. The one would be in our large intestine, our bacteria and vitamin B and K. Okay, so we let the bacteria live there. They in response produce vitamin B and K for us. Commensalism. That's two organisms living in close association where one will mainly benefit. And that would be barnacles on a whale. So it's the barnacles that are actually benefiting, not the whale. And then parasitism, two organisms living in close association where one benefits and causes the other harm. So example there, fleas on a dog. So the parasites will increase and thrive. So all biotic factors affect population numbers. So population dynamics in humans, we're going to look at, so it has their list of factors that affect human population growth. So there's 4 that we need to know: war, famine, contraception, and disease, and be able to give a quick explanation about them. Of war, so war reduces human population numbers, but following the war, we have an increase in birth rate. Famine, lack of food, causes malnutrition and death due to disease, so that will decrease population. Contraception, Increased availability of contraception has reduced birth rates, so therefore we're reducing population. And disease, now we have use of vaccines will help to reduce the incidence of diseases, for example, TB and polio. We have now improved sanitation, we have safe anesthetics, we've improved surgical procedures, new drugs. So all of this will help to increase the human population.